negative t. And yes, I will apply the power rule for t squared. But first of all, I have to identify that these are two different functions, function 1 and function 2. So we keep 10 outside. We differentiate t squared to get 2t times e to negative t plus t squared e to negative t times the inner function prime. Okay? I will factor out e to negative t and one of the t's, 1t. 10t e to negative t. So we took a t out. We took the e to negative t, so there is a 2 left inside. We took out a t, so it's minus. There is a t left, and e to negative t is out. So this is c prime of t. The reason I did this, it's not necessary right now, but it's easier to enter this function in the graphing calculator than all this, because we have to find c prime of 5. So, and in chapter 3, we will need this 4, and you will see why when we get there. So back to the graphing calculator. I will put it in as the second function, as 10t e to negative t, and then open parentheses 2 minus t, and close. So now I already have it plugged in. I already have the 5. So this is negative 1.011. 1.011. We need 2 measurement units. 1 measurement unit coming from the C function, from the concentration in this case. So it's ppm per, and the other one coming from the independent variable, which is per hour. But now let's discuss what they mean. So one of them is this, and the other one is this. Okay, so always please remember the rate of change has to have 2 measurement units. Okay, what is this? 5 hours after we took that medication, we still have in our system, 5 hours later, 1.68 parts per million concentration of the medication. Now, what does this mean? Is the following. This says, and if you want me to write this down, please let me know and I'll write it down. So this one is, after 5 hours, I took, let's say, aspirin right now. 5 hours later, I still have this in my bloodstream. After taking the medication, 5 hours later, the concentration in the bloodstream is decreasing by 1.011 part per million per hour. At that instant, 5 hours after I took the medication, the concentration in my bloodstream is changing, exactly decreasing by 1.011 parts per million per hour. Is this clear? Is this okay?
Yes.
Yes.
Perfect. Do you want me to write this down?
Yes, please.
Sure. So, C of 5. The actual parts per million after 5 hours. C prime of 5, the rate of change, the rate of change, which is decreasing, actually. A rate of change of concentration per hour at 5 hours. Good. Now I would like to continue with the derivative of the log function. So this is the last section we need to cover in chapter 2, derivative of natural log x. For some reason, this book does not present the the derivative of any base of x. So I'm not going to torture you with that. So I'm just going to discuss the natural log x. So when a function is given to us in the form of natural log x, and we are asked to differentiate this function, f prime of x is 1 over x. I should write times the inner function prime, but that's not needed because it's 1. Of course, this is the same formula for the situation in which we have the natural log of a function. So this prime is 1 over the function, but times the function prime. That's all there is to it. And I would like us to practice. And we're looking at page 216. Okay. So let's choose anything you'd like to differentiate from 1 through 20. So we are given functions that have natural log in them, and we want to differentiate those functions. Okay, that's my page 7. Which one would you like to start with, or I will choose?
You do 9.
9. Very good. So this is 9 on page 216, and this is y equals natural log x divided by x to the 5th. I know you're going to say, use the quotient rule. It's a ratio. True. However, I would recommend you change this into x to negative 5 times natural log x. Now, if I had something like this, I could have not done that. But I don't. I have one term in the denominator. You can say why. I think it will be easier to differentiate it as a product than as a quotient. So if you can, why not? So now y prime, or if you want dy over dx, is. Notice that now this is a product. The first function prime, negative 5 x to negative 6, times natural log x, plus x to negative 5 times natural log x prime, which is 1 over x. So now notice negative 5 x to negative 6 natural log x, and this is plus x to negative 6. Copy the base and subtract the exponents. From negative 5, I subtract 1, and I get negative 6. Notice what happens. X to negative 6 comes out, and what is left inside is negative 5 natural log x plus 1. Now you can go back and change it into a ratio if you want. No problem. Negative 5 natural log x plus 1 over x to the 6th. So in these situations, I think, and I recommend, use the product rule if you can, because it's a smoother ride. That's just my opinion. Okay, allow me to choose one here, like for example 13. Any questions on this problem? Any questions on this? Okay, I'd like to look at 13, because 13 is y equals natural log of some expression, a trinomial, 3x squared plus 2x minus 1. How do I differentiate this? Can anyone help with y prime dy over dx? So let me show the formula again. Natural log of a function prime is 1 over the function times the function prime. Can anyone tell us what to write? Ready? Please try. Anyone, please? So this is 1 over 3x squared plus 2x minus 1 multiplied by 6x plus 2. 1 over the function times the function prime. 1 over the function times the function prime. Let's also look at one of these equations if you'd like, or we can look at some word problems.
Can we do number 19?
Number 19, very good. Number 19. Okay, so h of x equals natural log of a messy situation. Of course, I will distribute x to the 5th plus x squared over e to 2x. Good. So in order to differentiate this, I highly recommend changing it into natural log of e to negative 2x times x to the 5th plus x squared. So now we're ready to differentiate. So h prime is log of a function. So it has to be 1 over the function times the function prime. So we have e to negative 2x, x to the 5th plus x squared, times the inner function prime. But the inner function is a product. This prime, e to negative 2x times the inner function prime, and times, sorry, I don't have enough room, times x to the 5th plus x squared, plus e to negative 2x times the inner function prime, 5x to the 4th plus 2x. Too messy to even mention, but I will try to clean it up a little bit. And see, these two terms have e to negative 2x in common. That will cancel with that, simplify. So e to negative 2x in the numerator. Then I have negative 2x to the 5th minus 2x squared. And then plus 5x to the 4th plus 2x over e to negative 2x, x to the 5th plus x squared. And that's it. So negative 2x to the 5th plus 5x to the 4th plus 2x minus 2x squared and plus 2x. And I've just realized that we can simplify an x. But that's it. There is nothing else that we can do here. So you can continue if you'd like to simplify an x. Now let's, any questions on this problem? It's messy. It's messy because of this product inside of natural log. So it's 1 over this function times this function prime. The first function prime is here times the second one plus the first function times the second one prime. And then I tried to simplify it a little bit. It didn't really work that much, but, and you can also factor out an x and simplify an x. I know we have only a few more minutes left, but let's take a look at any word problem, maybe 25, just to, even if we just started. So in 25, we have n of a equals 2,000 plus 500 natural log A. And they say, of course, A is greater than or equal to 1. N of A is the number of units sold. Number of units sold. A is the amount spent on advertising in thousands of dollars. So A, thousands of dollars. Okay, fine. How many units are sold when 1,000 is spent on advertising? Okay, so if it's in thousands, I have to plug in 1 in the function. So the function is 2,000. 2,000 plus 500 natural log x. Okay, and when I plug in 1, we know that this is 0, so 0 times 500 will be 0, so it will be 2,000, absolutely. But I needed to put it in there anyway. So n of 1 equals 2,000. What is 2,000? Units. That's part A. Good. Let's take a look at part B. Find n prime of A and n prime of 10. And then we'll see the rest in a minute. Okay. So they want us to find in part B n prime of A, and they want n prime of 10, which means the rate of change of the number of units sold when we spend 10,000 on advertising. Okay, so let's find first of all n prime of A. This is 0. This is 500 times natural log A, so it's 500 over A. Natural log A is 1 over A times the inner function prime, which is 1. So now in order to determine n prime of A, all I have to do is plug in A, which is replace A by 10. So then n prime of A equals 50, 2 measurement units. The measurement unit of the y variable, which is units, over the measurement unit of the independent variable, thousands of dollars. Okay? What do they represent? We didn't determine n of 10, but we can. But what does n prime of 10 represent? So when we spend $10,000 on advertising, then the number of units increases by 50. Okay, any questions? How much should be spent on advertising if 3,000 units are to be sold? So now they're giving us 3,000, which is the number of units. So 3,000 equals 2,000 plus 500 natural log A. And then we are asked to find the limit as n of n prime of A. Okay, so we know how to solve this. We have to clean it up first. Subtract 2,000. Then divide both sides by 500. And now, in order to determine A, if you remember, this is a very important property. Any exponential equation can be replaced by a log equation and vice versa. Any log equation can be replaced by an exponential. So how? How is this mathematically possible? Log base A of x is a number y. This is equivalent to And here's how we do it. A raised to this power equals this. A raised to y equals x. This is a super important property that says any log equation can be replaced by an exponential, and any exponential can be replaced by a log. So our equation, natural log a equals 2. We know that the base is e squared equals a. So a equals e squared. And what is e squared? And that is in thousands. So very simple. Here's your e. Oh, I didn't mean that. Here's the e and squared. So this is 7,389. 7,389 dollars. So in order to sell 3,000 units, we have to invest $7,389 in advertising. I know I have to stop. I'm sorry I held you 1 minute over. Sorry about that.